I don't do enough twirl. So I got to do, don't do the twirl, Mr. Miller. Are you tired of taking arithmetic means? Well, good news, there's also a geometric mean. So welcome to the video. It's a fun thing. It's actually kind of beautiful. There's an equation for it, which is fairly straightforward. And then there's this beautiful proportion that kind of lies behind the equation that I want to take a look at as well. And I'm in a good mood. Maybe if I remember, I'll just say, cue the cute picture of my son. We'll see if I pick up on that cue when I upload the video. So anyways, here we go. Geometric mean. We're going to find the geometric mean of 6 and 14. By the way, you just multiply the two numbers together and square root. We'll come back to that. But really, and here's the beautiful part. To understand the geometric mean, you just got to write a proportion. Here it is. You do this. You come over here and you say to yourself, you need to find a value of x that's bigger than 6 in the same proportion that it's smaller than 14. You need to find a number that's bigger than 6 in the same proportion. I don't even know why I put a jacket on, honestly. I realize I take my jackets off almost immediately in these videos. It just lets me move around a little bit more. You know, just in case the music comes on, I gotta dance, I gotta be ready. So that's it, that's the proportion you do. There's a picture of what this is. I want to draw it for you because I think the drawing is also quite important. So let me draw it real quick. Okay, so this is the geometry of the geometric mean. It says this: you're creating two similar rectangles, and you want the long side of the small rectangle to be the same as the short side of the larger rectangle. And what is that value of x that would allow these two to be geometrically similar? I told you, it's kind of beautiful. So we have a proportion. So we're going to solve it by cross multiplying. Let's go get it. All right, I have another video that kind of goes into a little bit more depth, I suppose, about cross multiplying. Right now, I'm just going to do it for you. So you get x squared is equal to 6 times 14, which is 84. By the way, that's a quadratic equation because the highest exponent is 2. We know how to solve this. We square root, right? We square root both sides. So we have x is equal to the square root of 84. So I'm going to put that up here more, trying to find myself some room. Square root of 84. Now, we should be simplifying radicals, assuming your teacher is showing you how to do that. At this point, you should simplify, so let's just go ahead and do that. That would be exactly the same as, what do we got? The square root of 4, it's 4 times 21, and times the square root of 21, which brings us to 2 root 21. Which is approximately 9.2. So the geometric mean of 6 and 14 is 2 times the square root of 21. That's exactly what it is. But rounded, it's about 9.2, which means if I go back to here, these are about 9.2 to create that. Cool, so these are geometrically similar rectangles. You can look here, we could have just done the square root of 6 times 14, which is, again, the square root of 84, and then you're done. Because that's the cross multiplication, right? Isn't that cool? You multiply them together because they're always going to be, one's going to be at the top and the other's going to be at the bottom, so they're always multiplied. It becomes quadratic, so you square root. That's it, you know? Pretty cool, pretty cool. So if you drew an object into this, you could perfectly replicate it here. The other thing that's kind of cool, I'm just going to add this because I just thought of it, is that you could rotate this rectangle up onto here, and let's move it over so we go over 6. So let's go over here. Let me just do this real quick. And now this rectangle is geometrically similar to there, but it's rotated. So if you were to say, for instance, but they're connected, right? They share a side. They share the side of 9.2. So let me draw something in both real quick. So I don't know if that was as helpful as I was hoping it would be, but either way, kind of cool. You get these two objects. I drew two vases, right, that are geometrically similar. One is, of course, rotated, but, and you're going to run into this at some point. If I go like this and I draw that line, and I draw this line down to there, now we have the geometric mean of the similarity in right triangles, which is its own thing. So that's the geometric mean. Not much else to say about it, okay, is you just, maybe we'll try one more example. Yeah, let's try one more example. All right, geometric mean of 10 and 12. Why don't you figure it out and hit pause. Unpause. All right, well, this time we'll do the equation first. The equation just says you square root the two numbers multiplied together. So you just do that. So it's the square root of 120. That's the right answer. Now, if you got to simplify the radical, go ahead and simplify it. So we would do, 120 divided by 16, 120 divided by 4 is 30. So that's going to be 2 square root 30. Or it's approximately 11, 11.0. Now, that trips me out a little bit because I don't want you to think I just averaged these two numbers, so I'm going to give you a few more decimal places. I mean, arithmetic average. So 9.5, there we go. It's not quite 11, so I don't want it to show up as 11 because 11 is the arithmetic mean. As a proportion, you would write this. You would say, okay, I need some number that is larger than 10 in the same proportion that it's smaller than 12. And then you'd cross multiply and you would get the square root of 120. And what you're really learning there is that if you had a rectangle that is 10 by 10.95, that would be geometrically similar to one that is 10.95 by 12. All right. I don't know if it was my best video, but you know, I don't know if you noticed, I'm not perfect here. Not perfect here, everybody. Thank you. But I'm okay with it. I like it. Anyways, take care of yourself. Be beautiful, because you are beautiful. You're intelligent too. Be silly and always trust your cape. All right.